Hi everyone, our project is AutoMIDI, a GEN-generated melody-based jazz music. My name is Xinjian Hao.
And my name is Yuzhong.
So our project used GEN, also known as the Generative Adversarial Network. It's a deep learning-based neural network that can estimate the generative models via an adversarial process. Right now, many musicians are using the deep learning techniques to help their composition works. Although there are other solutions like RNN exist, after comparison, we decided to use GNN for our project because the output of GNN models are very stable and desirable, and the feature very suitable for the task. And in this project, we aim to deploy a GNN-based architecture to perform music composing tasks. Instead of concerning traditional time series input of music notes, we proposed a convolution from the music audio files to image-based files to leverage the idea of convolutional neural network. This makes our model become a deep convolutional generative adversarial network in the field of images. In that case, our model has demonstrated a capability of reconstructing melody-based images after model is trained with a certain number of epochs. So talking about our methodology, the database we used is a collection of music datasets from the Kaggle community. This dataset consists of some classic piano MIDI files containing compositions of several famous composers. To pursue a better performance, the subgenres of the songs are constrained to unity, and most of the songs are selected from a Mozart's work. In that case, they're all identified by left and right piano parts. So for the pre-processing of our data, as mentioned before, we convert from the audio file to images. We're basically reading the melody notes with a Python library and then converted them to black and white pixels. I then put them together to form a fixed size images with 106 in width and 100 pixels in heights. For each row, it represents the number of different notes in the music track, while the column describes the length, which is also known as duration of that melody. On the bottom left corner of our poster is a visualization of this process. After we have these images generated, we rescale the pixels value to -1 and +1. This is because we used the triangular activation function for a more stable output and an easier way to help us to evaluate the result and our model. My partner Yuzhong will talk about the structure of our model nextly.
Okay, so for the model architecture we're using in our project, it is a kind of deep convolutional generative adversarial neural network. And our model mainly consists of two components, generator and discriminator. As for generator, it is trying to generate new plausible melody-based images from a d-dimensional random noise vector. And in our case, d equals to 100. And the discriminator is trying to classify images as real or not. And our generated adversary network are trained in adversary manner until discriminator cannot be able to identify the generated example as fake. So in our case, fake means non-melody based images. And for the better illustration, we also depict the model diagram here. So basically, discriminator model, as you can see at the left, is a convolutional-based neural networks that takes images with a size of 106 by 106 as the input. At the output, we are trying to identify whether this image is real or not. For generated model, it is kind of up-sampling neural networks that takes 100 dimensions random noise vector as the input to reconstruct the output, which is similar to our training data. So for the result part, to better understand the model was trying to do behind our method, actually we plot we are trying to plot the generated melody-based images using different models that has been trained with different epochs. So at the very beginning of the training process, you can see our model failed to generate plausible melody-based images. As you can see here, it's kind of like random noise or just lag. But actually, our model came to generate a plausible melody-based images along training epochs increases. As you can see, the result from epoch 90 here. And for the model evaluation, we also plotted the discriminator loss or generator loss versus epochs here. And you will notice that at the very first beginning of our training process, the discriminator loss or generator loss is pretty low. And it is because discriminator can easily identify the fake random noises from real melody-based images, given the fact that the generator model has not learned the information that can be used for reconstructing the images. But actually, by extending the duration of training, our model can successfully generate the meaningful melody-based images here. So for melody generation part, you can see for example, we just generated melody-based images by using the model that has been trained with 400 epochs here. And for performance demonstration, we also converted melody-based images to audio file or score file, as you can see here, for the purpose of evaluation. So to summarize our study, we are trying to identify the music composing as the images generation test by mapping the notes to the images. And we successfully generated the melody-based images by using GAN model. And actually, in our case, we only generate the melody-based images, but actually, you can learn more information about how we are generate the jazz music by utilizing the melody-based images. You can find more details in our final write-up. And this is all. Yeah, thank you.
Thanks for watching.